This is a video on how to use the Normalcdf function on your calculator. So this is when you want to find the area and you have your known value for your normal distribution. So we have a bunch of z statistics here, and we're going to use our distribution to find them. So I'm going to do the very first one because it's probably the trickiest because it matches up with a two-tail. All right, and so what we have here is a two-tail, so we're going to draw what's going on. So we've got a standard normal curve. So remember, your z statistics are normalized, and so my picture's not great, but it gets the job done. -1, -2, could have had the tail come in a little bit better, and -3. Okay, and the z statistic is 2.1, so I know I need to plot that down. So 2.1, so 2.1's probably a little bit closer than that, but there's 2.1, that's my z. And since it's a two-tail, that means not only do I need to shade in the region to the right of the positive value of my z statistic, but I need to plot the negative value of my z statistic. So here's z is -2.1, and I need to shade in the area to the left of that. So I'm looking for two different areas. I'm looking for the area here and the area here, and that together will make up my p-value. All right, and so one thing that we do know, if I had drawn this nicer, we know that our normal curve is symmetric, so the area over here is equal to the area over there. All right, so how do I find area? Is I want to go to the distribution button, so second distribution, and here's everything you're going to deal with your different distributions. So we're going to use the Normalcdf. We'll hit enter, and now what it wants is it wants a lower bound and an upper bound, mu, and sigma. Now, what you're always going to use for mu and sigma will be 1 for mu, and 0 for mu, and 1 for sigma, because you're on the standard normal curve, which is centered at 0 with a standard deviation of 1. If you do not have this prompt screen that pops up, then what you'll have is something that looks like this on your prompt screen, and then the blinking cursor will be right here. And what it's looking for is exactly what I have listed, is the lower bound, comma, the upper bound, comma, your value of mu, comma, sigma. Well, this is always going to be 0, and this is always going to be 1. So whatever lower bound you're looking for whatever upper bound you're looking for. We have a couple different ways we can tackle this problem. One way is to say, well, I know I want to go from -infinity up to this and find out what the area is right here. So here you can see I've got -infinity in here. The way that you get that is -1. That E button is right here, those big double E's, and this is calculator speak for scientific notation. So when you see this, -1e to the 99, what it's really saying is -1 times 10 to the 99, or -1 with 99 zeros behind it. It's about as big as you can go without having overflow in your calculator. All right, that means that your calculator can't handle it anymore. Now upper, if I just went to 2.1, well, that wouldn't work because I don't want any of this whited out area. I just want this area. So I'm going to go to -2.1, and I'm going to stay on the standard normal curve. So for those of you that have this, you're going to see this is what it looks like. And I will just hit, and the comma button is right here by the E's. We'll hit enter. And so this one side right here is 0.01786. So what I could do is I could use the symmetry, and I could multiply this by 2. And so I know my total p-value is going to be 0.035. Oops, there's my 5 rounds up to a 6. There we go. 0.036. There's my total value. The other thing I could have done is I could have found the area in the middle, and that's the area I don't want, and since the total area is 100% is 1, I could have taken this area and subtracted it from 1. So I could go 1 minus, and then go second distribution, go to the normal CDF again, make sure you're using CDF, and so here my lower bound would be negative 2.1, and my upper bound would be positive 2.1. Make sure you're using the negative sign and not the minus sign. If you use the minus sign, it'll give you syntax error. And so again, what I'm doing is I'm finding this area in here, centering it at 0 with a deviation of 1. And look, at the beginning, I subtracted it from 1, and we'll hit enter, and I get the same number back because it's the same thing. So that's for a two-tail. For a one-tail, it makes it much easier, whether it's an upper bound, whether it's a right tail or a left tail. And you can see from the picture, always draw your diagram first. Wow, that was really bad. Oh, I can't draw curves. Always draw your curve first, but sometimes don't. Just make a little bow. There we go. 0, 1, 2, 3, 1, 2, 3. Here I'm going for negative 1.09. And we're going to look here, and this is a less than, so this is a left tail. And so we would fill it in this way. And so you could see I do exactly what I did before and say negative infinity to negative 1.09. Whereas on the next one, I've got 4.25. 1, 2, 3, 4, 5. So right here, and I'll do an upper tail, and now my lower bound will be the z statistic, whereas up here, my upper bound would have been the z statistic. The main thing is making sure that your upper and lower bounds match up with the number line. If they don't match up with the number line, your calculator will freak out and say, "What are you doing?" All right, well, I hope that's been useful.